Hello everyone, welcome back to the channel. My name is Danny and today we're going to talk about channels in Rust. So the last video I explained threads and how do we use arcs and mutexes and RW locks in order to get access to read and write a particular data structure inside of the main function. But today we're going to use channels in order to send back and forth values between threads. So I'm really excited and let's get right into it. So as always, I already have all the imports here so that we don't waste time. The first thing you need to understand is that MPSC, which is multiple producer, single consumer channel, that's what's going to create a channel for us. And usually you would want to initialize what the data structure type is, the generic type that's going to go inside of that channel. What are you transferring? What are you moving back and forth? In this case, let's just say string, all right? And then this is going to return a tuple. So it's going to be two values that we're going to destructure. And you can name these values whatever you want. I'm just going to say sender and receiver. All right, just like that. And now we have a sender and a receiver that we can use inside of our threads. Oh, hold on 1 second here. That's not right. There it is. Okay, so now we have a sender and a receiver. So let's go ahead and initialize a new thread. We're gonna say thread spawn move, same as before. We've been over this with the last video. So inside of this thread, we're gonna send a message. We're gonna say sender.send, right? We're gonna say message from thread 1. Okay, and then convert that to a string. Make sure to unwrap that because it can fail, and if it does fail, we want it to panic. And then here, let's make sure we join the thread so that it's able to perform all the function it needs without going out of scope. And then finally, here, how are we going to receive the message on this end? So there's a few ways we can do that. So the first way is going to be just a simple receive method. So we're going to say let message equal receiver dot receive, this one right here, right? And it's going to return a result, either string or an error. So we need to unwrap that as well. Of course, in production, you would probably want to handle that a lot better using a match. And we'll get into that in a few. So for now, let's just go ahead and print out the message. Received message in main. All right, and it's gonna print out the message here. So let's see what happens now. Okay. Cargo run queue quiet. All right. Okay, so we were able to receive our message. So there you have it. You're able to transfer value between threads. Okay, so in this case, we transfer a string, a message string from inside of a thread, and we receive it on the main function. Now, let's say what happens if the sender never sent the message, right? So let's say we comment this out and the message was never sent. What do you think will happen here at this level, on this line? So let's try it out. So nothing happens, right? So basically why is because receive as a method is going to block the thread, right? So it attempts to wait for a value on this receiver, returning an error, but it will also block the current thread if there is no data available. So it never even make it to line 15. It's just going to stop here at line 14, and it's just going to keep waiting for the message that never comes because we never sent one. So that's the drawback of the receive method, is that it's completely blocking. This is okay if you have a designated thread just to receive messages, so that's fine. They can just sit there and wait all day long, but you don't want to do that on a main thread. So you do have to understand the nuances between the flexibility and the rigidity of the receive method. So we're going to go ahead and exit out of that with Control C, and let's try something different. Now, like I said, there are multiple ways to receive messages. So instead of just using receive, what we can do is just use try receive instead. So it's going to be try receive, okay? And for this one, I'm not going to use unwrap. I'm going to go ahead and handle the error like I should, as I should in production, right? So we're going to say let message equal. So basically what try receive does is it's an opportunistic check, right? It's gonna try to probe and see if there's any messages down the channel, and it's just gonna check real quick, and if there's none, we can handle the error however we want. Either we want it to panic, or we can handle the error and then it'll go to the next line. So it's not going to be blocking. So it's a lot more flexible. However, it is quick. Like it's going to check like in a millisecond, just however fast your CPU can handle the processing. So for this one, let's say let message equal receiver.try receive, and then we're going to try do a match on the message. If we get an OK with the value wrapped inside it, we're gonna print out that value. So I'm just gonna copy this. We don't need the semicolon, it's gonna be a comma. So instead of MSG, it's gonna be M, which is the value that's wrapped inside of the message. And then if we get an error, we're not gonna do anything. So it's just gonna be that and nothing. All right, so basically what this is gonna do is it's gonna check really fast to see if we have a message, and it'll go to the next line in the main function. So we're gonna say next function, next line of code in main, just so we know when we move on from this particular block of code right here. All right, so let's see here. So let's try it where we don't send a message. So as you can see, it just goes straight to the next line of code. If we do have a message, however, all right, let's uncomment that and let's have the sender send that same message again, and let's see what happens now. Okay, the reason why, like I said, is because first of all, the join handle was way down here. So the thread never even got started. We didn't give it a chance, especially with this. Like I said, it's a quick probe. It's like a millisecond. So what we need to do is probably put a for loop into it, right? So we're gonna say for I in 0 to 10,000, right? We're gonna iterate from 0 to 10,000, and we're gonna put all of that in there. And let's also say that we receive message in iteration I. So let's see how long it takes for us to receive that message. Okay, so let's go. Okay, see, we were able to receive the message in iteration 4608. So that's pretty good, right? So it was counting to 10,000, and as soon as 10,000 is done, it'll move on. So just to test it out, we're gonna do a sleep here. Let's see, sleep duration from sex. Let's do 3 seconds. Okay, let's say it takes 3 seconds for this message to get sent, and I think my computer should be able to iterate from 0 to 10,000 in less than 3 seconds. So that means we won't receive anything, so we shouldn't get the message. Yeah. Okay, so as you can see, boom, the program does exit. It was able to move on past this and goes to the next line of code in main. So everything is working perfectly just as we thought. So like I said, try receive is gonna try to probe one time. It's just gonna probe one time into the channel to see if there's any message, and of course you can wrap it in a for loop. You can do other things to it to make sure that it tries many more times, but basically that's what it does, right? It is non-blocking. So the next one that we should try is called receive timeout. So what that's gonna do, I'm gonna go ahead and comment this out for now, and we're gonna do receive timeout. Let message equal receiver dot receive timeout right here, and we gotta specify how long. So it's gonna be a duration from seconds, and let's do 3 seconds. Okay, so what this method is gonna do is it's gonna check for 3 seconds. So it's basically the same thing as this, except I think it looks a lot cleaner, right? So if someone look at this code, they can kind of tell what's going on. Oh, okay, we're checking for a message inside a channel, and there's a timeout, so that we're checking for 3 seconds. After 3 seconds, if we still don't have a message, we're just gonna move on to the next block of code. That's a lot cleaner, in my opinion, than this right here. So we don't need this. Let's go ahead and delete that. Okay, so now let's go ahead and handle the errors and everything. Let's see, match message. Okay, If there is an okay, then we're gonna print it out. Received message, and print it out here. If it's not, then same as before, we're not gonna do anything. Just leave it blank. Okay. All right. So now we're gonna check for 3 seconds. So let's try. Let's see. Let's try to see what happens if we. Okay. So we won't sleep here. We should be able to get the message right now. 1, 2, 3. So as you can see, we were able to receive the message because within those 3 seconds, we were able to send the message down the channel. Now, what happens if we sleep for 3 seconds before we send the message and we only check for 2 seconds? So obviously, this is not going to work when we shouldn't receive a message, right? So let's try that. Okay, as you can see, it went to the next line of code and then it exited the program. It wasn't able to get a message. So there you have it. In my opinion, this is a lot cleaner. I like this better. It looks better to me. And I can just, I can change the seconds here in the arguments. It's a lot better than trying to do a for loop and using the try receive. The try receive has its own place and time. But in my opinion, this looks a lot cleaner. All right. So now there is one more way for us to check for messages, and it's just using the iterator implementation, the iterator trait, and we're just gonna loop over the receiver and get the message that way. So let's try that. So let's message, no, actually for, excuse me, message in receiver, okay, and then we're just gonna print it out, received message here. Okay, so let's see what happens. Okay, so we don't need this. All right, let's see. Okay, so as you can see, it works, right? So what does that mean? What is this iterator over the receiver? It basically just check the receiver, and this, for every message that's in there, it's gonna print it out. So we send multiple messages, right? So we're gonna do message 1, message 2, and message 3 here. Okay, we'll send 3 different messages. It should be able to get all 3 messages. There you have it. So how does that work? How does this loop even know when to stop? It knows when to stop when the channel is broken, and the channel is broken when the sender or the receiver go out of scope. So as you can see, the sender has been moved in here into the thread, and so when the thread exits, the sender's dropped, right? It's dropped. It's no longer in scope. So the receiver or the channel knows that the channel has been broken, so that it stops looping. So we can send 100 messages in here, and it's basically gonna keep receiving messages. It's unbounded, so to speak, right? So yeah, that's another great way to receive messages, especially when there's multiple messages coming in, right? So the next one that we want to talk about is a sync sender, right? So it's going to be a sync channel, and we'll explain as we go here. We're going to start a sync channel instead, right? And it's going to return a sync sender, and the receiver is going to be the same. So as you can already see, the only thing that's going to change is the sender. How does that work? Let's see, MPSC sync channel, and we need to take an argument of bound. So basically what bound is we're going to put in a number of how many messages we want to top out inside of the buffer that we're sending in. So let's say if I put 2 here, what that's going to do is it's going to say the buffer is only going to be able to accept 2 messages at a time. And so it's going to send these first 2 messages, it's going to store them inside the buffer, and until I read those messages out, until I receive the message, it won't continue to send the 3rd or the 4th or the 5th one. So it's only going to send 2 at a time inside the buffer, and the only way for us to send more messages is if the receiver start receiving those messages in the buffer. So does that make sense? So it's kind of like a queue, right? So if we do 2 here, and in order for us to see this, what I'm going to do is I'm going to put a sleep here. Sleep duration from seconds, and let's do 3 seconds, right? So we can see we have enough time to see what's going on. So if I run this method right now, I mean if I run this program right now, what it's gonna do is it's gonna say let's see, how am I gonna do this? Send oh, okay, you know what? So let's go ahead and print out some text here so that we know when it starts. Sending 1, okay, and then once it's sent, we'll do sent 1, right? So that we know exactly where it starts and where it stops. So this is sending 2, and then we're gonna say sent 2. All right, and then we're gonna say sent 3 here, sending 3, and finally sent 3. Okay, so let's see what happens. So now we have a bound of 2. It should say sending 1, and then sent 1, and then sending 2, and then sent 2, and then it's gonna wait for 3 seconds, and then it'll start receiving the messages, and then it'll say sending 3 and sent 3. So you're gonna see two of them get sent at the same time, and then the third one is gonna be delayed by 3 seconds. All right, so let's see. Go ahead and clear this out. Okay. As you can see, you see how it only sent 2, and right before it was able to send the third one, it stopped. And then by the time we finally start receiving the messages, by the time we take it out of the queue, the third one was able to get sent. So what happened if we do 1? As you can imagine, it's gonna be the same thing. It's gonna say sending 1, sent 1, and then maybe sending 2, and it'll stop right here. It'll stop right here, and then wait for 3 seconds, and then it'll start pulling the messages out of the queue, and then the second message is gonna finally get sent. So let's try that. There it is. It wasn't able to finish sending the second one until the 3 messages get received, and then it was able to send the second one and then the third one. Now, what happens if we go to 0? So if we go to 0, that's what's called a rendezvous channel, right? Is that what it's called? A rendezvous channel, if I remember correctly. Yes, it's a rendezvous channel, meaning that it won't start sending anything until the receiver meet up with the sender. So until the receiver gets turned on right here, it won't start sending anything. So basically you probably only see sending 1 here, and then I'm gonna do 5 seconds so that you can really see the delay. So it's gonna say sending 1, and then 5 seconds, and then all of this is gonna flood in at the same time, right? There it is. See, 5 seconds. Boom. Now the rest of them gets flooded in. So as you can see, sync sender or sync channel, it's able to give us the configuration so that we can adjust however big we want the buffer to be that holds these messages. And keep in mind, it's always going to get sent in the same order. So that's the cool part about this, is that whatever order you send these messages in, it's going to be the same exact order when we finally turn on the receiver and start pulling it out of the queue. So that's super neat. So yeah, that's the sync channel. Okay, so now the final thing that we want to talk about is, let's talk about how do we handle the receiver side, because the sender side, let's see, do the same thing. The sender, receiver, MPSC channel, string. Right. Okay. So the same thing as before. How do we use multiple senders? How do we do multiple senders? Right. Because the last example we did, we only had 1 thread, and when that thread moves the sender inside of that thread, we don't have a sender anymore. But that's fine, because we didn't want to use another thread to send messages. But what happened if we want to use another thread to send messages to the main function as well? So let's try that. Okay, so thread spawn, okay, move. All right, so sender, we're gonna send message 1 from thread 1. Okay, to string unwrap. Okay, pretty simple, right? Straightforward. Let's make sure that we join it. All right, so now we have the first sender. So what happened if we do another thread here? Sender.send message 2 from thread 2. So what happens if we do that? As you can see, it's not going to work because the sender value has already been moved. But the cool thing about sender is that you can clone as many of them as you like. So when you're out here, let's go ahead and say sender 2 is equal to sender 1 clone, right? And then for this one, we're going to use sender 2 instead. Okay, and that should work the same exact way. So now we have two different senders from two different threads sending messages into the main function. So let's make sure we join that. Okay, and then we can go ahead and receive the messages the same way as before, which is for message in receiver. We're going to iterate over that, and we're just going to print it out. Received message. Let's print out the message, and that's it. Right? So let's see what happens here. We should be able to receive both of the messages with no problem. Wait, what's going on here? Oh, unwrap. Okay, cool. So we finished with that. So we were able to receive, so we can send as many, we can have as many senders as we want. We can clone as many senders as we want. Now, what happens if we try to clone the receiver? What if we say the receiver2 equal receiver.clone? There's no such thing. There's no such thing as a clone method on receiver. Why? Because the name has implied that it's multiple producer, single consumer. So that means that you can have as many senders as you like, but you can only have one receiver. Only one receiver can receive messages. And you can have as many senders as you want, but only one hub is going to receive all of those messages in one place. So what do? How do we let's say, how do I send a message from the main thread, right? And then let's say if I want to do, I'm gonna do another sender here. Let's sender 3 equal sender.clone, right? Let's say if I wanted in the main thread, I want to do sender3.send message 3 from main. So that's a little different. Unwrap. All right. So let's say if I want to start another thread, thread 3, and I want to receive it in there, right? Receiver dot I'm just gonna use the receiver method. I'm okay with blocking this thread, like I said, because this thread 3 doesn't have any other things to do besides just waiting for a message. So I'm okay with just blocking it. So let's say let message equal receiver dot receive dot unwrap, right? We'll panic if we get an error, which we won't because it's gonna sit there forever just waiting for the message. So what happens here? I'm gonna print it out. Received message from main. No, in thread. So let's see. Would that work? So we cannot use the receiver value. We cannot move it inside of thread 3 because we were never able to clone it. We don't have a clone function, a clone method for receiver. So how do we solve this problem? Well, if you remember from the last video, we can use arc, right? And mutex. So basically it's going to be the same as the last video. So we get to use that same concept again, just to reinforce our understanding. So what we can do instead is say, let's see, say let receiver equal arc new, right? And we're gonna wrap that inside of a mutex. So just like that. So now the receiver is an arc pointer to a mutex value of a receiver. So each time that we want to receive a message, we're gonna have to do a little bit more than just doing this. What we're gonna say is for message in receiver. So how do we access the value inside of a mutex? We gotta lock it, right? Lock dot unwrap, right? So then now we get the value, but then we also have to iterate. So it's gonna be iter, right? So that should work. Same thing here. We're not, instead of moving the value of receiver inside of thread 3, what we're gonna do is we're gonna say let receiver clone equal arc clone receiver. Oh, it's gonna be a reference to self, so it's gonna be receiver here, just like that. And then we can move the receiver in here. So we're gonna use the receiver clone instead. And once again, we're gonna have to unwrap it, unwrap the mutex and the arc. So we're gonna say lock, right? And then we're gonna say unwrap. And then after that, we can get the receive method. And that's gonna return a string. Of course, we're gonna unwrap it as well, since it returns a result of a string. And now we got the string here. So let's make sure that thread 3 also gets joined, so that, all right, so let's see what happens here, right? So we should be able to receive all 3 messages, and the last message is going to be received inside of thread 3. Okay, let's try that. Oh, it's blocking. It's blocking. So I think what happens is because there's still a sender here. Yeah, I think there's still a sender that's not dropped, and therefore, because the sender 1 and sender 2 was dropped inside of the thread, however, sender 3 was never dropped. So we're gonna have to drop that in order, before we can finally receive the message here. So let's see, what if I say drop sender 3? Can I do that? Why is it not working here? Let's see, receiver clone, right? We got the clone, we got the message, let message equal receiver clone receiver, and that's blocking. So it just keeps blocking and it doesn't, Thread 2 join, drop with sender 3, sender 2 has already been dropped. Alright guys, so I know what went wrong. First of all, I didn't need to clone the receiver clone again. It's gonna move inside of this thread. However, it's gonna just increase the strong count of the ARC, which is the arc of the clone. So all it's gonna do is just copy, instead of a deep copy of the entire data structure, it's just gonna do a shallow copy of a pointer to that data structure. And we're going to use the same exact one, so we don't even need to clone it for the receiver. So as long as we have an arc and a mutex on it, it's fine, right? We could just move it and it'll still be here available if we need to use it again outside its function. So that's the first thing I did wrong. The second thing I did wrong was that the reason why it wasn't working before and it kept stopping at message 3 was because of this for loop right here. Now keep in mind what I said, it's gonna keep looping, looking for messages right here. It's gonna basically block off right here until everything is dropped. So since we still have senders in scope, it will not drop and it will just keep going forever and forever. So that's why we could never get down here to the part where we actually sent the third message and receive it in the third thread, right? So let's go ahead and delete that. Now that we know what's wrong, we're just gonna keep it simple just to show the concept. So the first thread is gonna send the first message here, okay? And then we're gonna receive that right away, right? We're gonna receive the first message in the main, and then the second thread, we use the sender clone in order to get the second clone of the sender, and we're gonna receive that second message here. And then for the third one, we're gonna do the same exact thing, except we're sending from the main function, and we're gonna receive in the thread here. So we're gonna use the same method. We're gonna do a receive timeout for 1 second, and then we're gonna catch that message, and we're gonna print it out, and then go back to the main function here. So let me go ahead and clear up everything. Call go run, and it should get all 3 messages. All right, so there it is. As you can see, the program is finally working. We got all the way to the end, and we caught a little hiccup, but that's okay. That's how it is. That's how it is with coding. That's how it is with programming. That's software engineering. But now we know, right? So whenever we have a for loop that iterate over the receiver, it's gonna keep blocking. It's gonna keep waiting for more messages until everything is out of scope, until the channel is broken. It's pretty much. And in this case, the channel wasn't broken. We plan on using the sender again down here at the bottom, so that we can send another message from the main, and then catch it inside of a new thread. So that's why it was blocked off at message 2, and we're never able to get to message 3. So that's that, guys. I hope you enjoyed this video. The next one, I might do a real life work example of this particular concept, just to drill it in a little bit more. But yeah, that's it for now, and I hope you guys really enjoy that, and I hope it helped. Have a wonderful night, everybody.